We present a system for novel view synthesis called Simply. Our approach can take an arbitrary number of source views as input and produces a multi-layer proxy geometry for the scene in a few seconds. The obtained representation may be rendered in real time with modern graphic engines such as OpenGL. The main task of novel view synthesis is to predict what the scene looks like from the new viewpoint, given a set of input images and the corresponding camera parameters. Various recent methods have tried to solve this task by running a dedicated optimization procedure for each scene. This scenario is more suitable for devices where we cannot optimize the parameters of our model. Also, we aim to construct such a representation for the scene which allows for fast rendering even with limited computational resources. We select several metrics essential for applications and evaluate the existing baselines based on them. Note that this is a qualitative estimation since some of the methods did not report the necessary measurements. Despite this, we see that many areas on the plot are still unrevealed by existing approaches. Our approach called Simply addresses this gap. Although it is still not perfect, the proposed model allows real-time rendering and requires low memory storage without sacrificing quality. Here we present a short overview of our approach. First, we process each input image to extract the features. Next, we aggregate all this information to initialize the multiplane representation in the feature domain. Then we conduct an error correction step, merge rigid planes to the adaptive layers, and further improve the textures of layers with the information collected from source views. The resulting representation consists of semi-transparent RGB textures and depth maps for each layer. This representation can be rendered with a rasterization step followed by the overcompositing. In this example, textures of 4 layers are shown. Now we present results for popular benchmarking datasets. In this slide, you can see the results produced with our model for challenging scenes from the SWORD dataset. As mentioned earlier, the main advantage of our method is the speed of inference. Here we can see the results of one of our baselines, IBernit, which estimates a radiance field based on source views. It runs a forward pass through a neural network for each new frame. In contrast, our model builds the scene representation only once, and afterward, a new image is rendered in real time. Therefore, the time to generate this short video differs dramatically for the two models. Another baseline is the local light field fusion model. For each source frame, a scene is represented with 40 rigid semi-transparent planes. To produce a novel view, representations that are nearest to the new viewpoint are fused. Our model is still better in visual quality while utilizing only 4 adaptive layers in this example. We demonstrate that the outputs of Simply look much more plausible than the results of both baselines, and rendering is much faster. This video was generated from 8 input views. Also, we study the influence of the number of layers in the estimated representation. As expected, the perceptual quality improves when more layers are employed. Therefore, we need to trade off memory consumption for the plausibility of the outputs. Similar to the approaches based on multiplane images, Simply has a limited ability to handle view-dependent effects. In this video, our model produces image matching artifacts on the flat surface. Another common problem is that our approach cannot in-paint the occluded regions which are not present in source views. Thank you for watching.